In this video, you are going to learn how you can create your very own crypto. We're going to create our very own crypto named Sixpack. Why Sixpack? Because what we cannot have in real life, we must have plenty in metaverse. But more importantly, we're going to learn the crypto creation steps. This is not going to be a video where you copy paste some stuff, run a command, and your crypto gets created. We are going to understand how is the process related to the blockchain, what is the role of the smart contract in it, what are the tools involved, and very importantly, end-to-end design flow. If you are someone who is trying to get into crypto, Bitcoin, and trying to get a job in this space, this is very important. Then we are going to go and create our own crypto along with code walkthrough, but note that no coding skills required to create your own crypto. So you can skip that code walkthrough part if needed. This is going to be a packed video, so I've included the timestamps for your viewing convenience. For those of you who are new to the channel, my name is Raj. I'm a senior solutions architect at AWS. I am also a published best-selling author, public speaker, and a tech advisor at a crypto startup. All right, let's get started. So the first question is, who creates the crypto token? The answer is smart contract. For those of you who are not sure what is smart contract, what is blockchain, I highly recommend watching my crypto fundamental tech stack video before watching this one. But just in brief, smart contract are pieces of code or program that resides on blockchain. And any transaction that needs to happen on the blockchain and then you want to execute any sort of logic, you need to execute a smart contract. So some examples of smart contract are every NFT marketplace. So let's say someone wants to buy an NFT for 20 Ethereum or something. So your smart contracts runs that logic that, okay, you need to get 20 Ethereum to buy this NFT and other if-else conditions. They're also used in all the stores and websites accepting crypto. Crypto swap, also it comes into play for creating new crypto. So the smart contract that creates the crypto creates the initial supply, and it provides different transaction functionalities such as transferring crypto from one account to another, swapping this crypto for another crypto, rewarding the miners, and more. So now let's go over the high-level steps. So one thing to keep in mind is when it comes to crypto, there are two different things. The cryptocurrency and crypto token. To have your own cryptocurrency, you need to create your very own blockchain. So that's a little bit intense, but a lot of the crypto that's out there, they're actually crypto token. So crypto token utilizes existing blockchain and then creates a new token. Some of the popular tokens are like Shiba Inu, Tether, BNB token, etc. For our project, we are going to use Ethereum blockchain, which is the most popular blockchain right now. And even within Ethereum blockchain, there are different blockchains in there. If you want to test something, you can use Rinkeby testnet. That's what we are going to use. And then the production Ethereum blockchain is mainnet. Like I said, smart contract is the heart of any crypto tech stack. So for development, we are going to use Remix as the IDE. Solidity will be the code. And then we are going to use Open Zeppelin Ethereum project framework. Don't worry, we're going to go over all of this so you will understand all of this perfectly. So once you create a smart contract, before you deploy to even Rinkeby, testnet, or mainnet, you want to test it out in your local machine. So you'll deploy it in a JavaScript virtual machine, and then you do some local testing. If you are happy with it, then you are going to connect your local development environment to the Rinkeby testnet blockchain using a MetaMask crypto wallet. So anything that you need to do in blockchain should be associated with an account number. So MetaMask is a crypto wallet that provides you the account number as well as connect to different blockchains. So after the connection is established, you are going to deploy this smart contract to the Rinkeby testnet blockchain, and everything in this blockchain is open. So anyone can see what transactions are happening. And to check the blockchain transactions, we are going to use Etherscan. And since this smart contract creates the crypto token, we can get the token address using Etherscan. So each token, besides its name and the code, will also have like a hash token address. and then you need to use this token address to register this token to different exchanges. So at this point, your token is created, but all the token will be in your account. And it's not good to have all the token in your own account. That means no one else can use this token to buy or sell anything. So what you need to do is create liquidity. So liquidity is you transfer some of your token to the market so that other folks can buy this token, use this token to do trades and all kinds of stuff. So for that, you need a marketplace. We are going to use Uniswap as the DeFi marketplace. And let's say we create 1 million token. We are going to release half of this token to the market to create liquidity. So at that point, your token is established, and then you can use Ethereum to buy this 6-pack token or vice versa. And if everything is fine, you can deploy the same contract into Ethereum production blockchain, which is mainnet. All right, that's it. That's the end-to-end flow. Now that we understand the high-level flow, let's jump into doing the demo and create our very own token. Let's open up the Remix IDE first. Remix IDE can be run both in the browser and in desktop, which is pretty convenient. Just Google Remix Solidity and the first link should be it. Click the first link, Remix Ethereum IDE, and the IDE should open in your browser. I'm going to make it a little bigger. To create a new workspace, click this plus icon and give a name. I'm going to create this workspace _ 6-pack token. Click OK. Next, we have to write the smart contract in Solidity. Don't worry, we don't have to start from scratch. We are going to use the OpenZeppelin framework. So you can think of OpenZeppelin as some open source library of some contracts with a lot of functionality built in so that you don't have to start from scratch. And you could see a lot of well-known crypto companies such as Coinbase, Ethereum Foundations, BitGo, they all use OpenZeppelin. So you can just Google OpenZeppelin or go to openzeppelin.com, and then on the products, click contracts, and then click get started. Since we are creating a token, we are going to go under tokens. There are different kinds of tokens such as ERC20, ERC721, 777, 1155, etc. ERC20 token contract keeps track of fungible tokens. So basically you could say that one 6-pack token or one token that you are creating could be equal to 0.1 of Ethereum, etc. For our purposes, we are going to create a ERC20 token. Some of the other popular ERC20 tokens are Tether, Chainlink, Shiba Inu, Binance Coin, etc. So if I click ERC721, they are used for real estate, voting rights, or collectible. So for cryptocurrency and crypto token, ERC20 is the most suitable one. Now here, they give an example of how to create a own token called GLD. So I'm going to copy this code using this copy icon, and then go back to the Remix IDE, and under our newly created workspace, click this create new file icon, and I'm going to name this mytoken.sol as in Solidity, and then paste your code. Now to compile this code, click this Solidity compiler. So you have two options. Every time you change code, you can click this compile the name of your program, or you can click auto compile. I'm going to click this auto compile so that we don't have to come and compile every time. And you could see this green check mark. That means our code is compiled correctly. Now go back to the file explorer, and you would see some more files have been imported. So now let's go over the code. So if you're not interested on going over the basics of this code, you can skip this part. I have given the timestamp, and you can go to the next part. The first line is just for version. You cannot really do anything with that. This is the important part. It is importing this ERC20.solidity. And you can see as soon as the program got compiled, it imported this ERC20.solidity. So if I double click this, it is going to open it. So this is a Solidity class that comes with a lot of predefined functions, such as how to create supply, how to transfer the coin, how to mint it, etc. So if I go back to mytoken.solidity, all it is doing is instantiating a class named GLD token, and it is referencing this class ERC20, and it is running a constructor. So as soon as this class gets instantiated, this constructor gonna run, and it is expecting initial supply. So this will be the total amount of the token that this class is expecting. Then it invokes the underscore mint function with the initial supply number that you have provided. So if we go back to ERC20.solidity and search for underscore mint, so this underscore mint function under this ERC20 class creates the total supply and then allocates or transfers to the account that is invoking the smart contract. There are other functions here as well, such as transfer, which is transferring some tokens from one account to another account, balance, which shows the balance of a particular account, etc. So you could see by importing this ERC20.solidity, we did not have to start from scratch, and then you can build other functionalities on top, such as if you want to reward this token to the miners who are adding blocks to the blockchain, you could do all that. For this demo, I'm not going to add any additional functionality. I'm just go with the out-of-the-box default functionalities. Now that we understand the high-level basics of the code, let's change this code a little bit. So instead of GLD, I'm going to name the class 6pack token. I'm going to name it 6pack, and the short symbol will also be 6pack. Okay, this should have been automatically compiled. Now we have to deploy it. To deploy the smart contract, go to this deploy and run transactions icon. There are multiple choices in the environment. So when you select this JavaScript VM, either London or Berlin, this is basically just doing everything in your local and in memory only. It does not get implemented to any blockchain, either the test blockchain or the production mainnet blockchain. So you can select either virtual machine. And note that this account 0x5b3, this is the account which is executing the smart contract. That means the initial supply or the full balance will be allocated to this account. Don't touch the gas limit or the value. You do need to click this arrow in the contract box and select mytoken.solidity. And then click the arrow besides deploy, and here you have to give the initial supply. So I'm going to go back and copy this number here, go back here, paste it here. So before I paste it, the format of this is UINT256. So U means unsigned. That means that this can only be a positive number, cannot be a negative balance. INT means it's integer, 256 means it's 256 bits. So let's paste this. So this basically is creating 1000 amount of the token. So the number is 1000 and then 18 zeros at the end to convert it into this UINT256 format. And then click transact. As soon as I clicked the transact, you could see this entry came here, 6pack token at this account. Note that this account number does not match the account number that actually created the smart contract. So don't get confused. All the balance will be under the account that actually executed the smart contract. So let's click this arrow, and here it's going to list all the functions under this ERC20 class. The name of the functions that are in blue means they are just for reading information purposes, and the function names that are in orange means they are going to change some data. So let's start with the easy ones. If you click the name of the token is 6pack, a symbol is 6pack as well, total supply is the number, and then let's check the balance of. So just to show you, if you copy this account number and paste it here and click balance of, see the balance is 0. The account that actually started the transaction has the balance. So if you click copy this account number, go back, and then paste the account number here, click balance off, you could see the full balance is allocated to the actual root account. Also, if you're wondering why this is 99.99, so in actual blockchain world, every time you run a smart contract or deploy a smart contract, you need to pay a gas fee. Even though this is running in some local simulated virtual machine and not in blockchain, they want to keep the experience as consistent as possible. So every time you run something that changes the information in blockchain or adds a new block, that is going to deduct some of your balance. So now that we deployed this in our local memory and we understand that the whole balance goes to the deployer account, now to deploy it to any blockchain, we need a deployer account. And to create such account which will allow you to deploy the smart contract to the blockchain, we are going to use MetaMask. So click this icon and click download now. And then this works as an extension. So I'm running Chrome, so I'm going to install MetaMask for Chrome. Okay, add extension. So go ahead and set up your wallet, go through all this stuff. Then something like this should open up. And on the top right, it shows which blockchain this MetaMask is connected to. Ethereum mainnet is the production account. So we want to test it out in our test account. So click this arrow and then click show hide test network. It's going to take you to options and then enable show test networks. All right, then cross it out and then click this icon again and then select Ring-B test network. Now in your screen, you will have 0 Ethereum. So now you need to get some Ethereum because remember, to do everything that changes the data in blockchain, you need to spend some gas fee. So how do you do that? So come to Google and type Ring-B faucet and then select the second link. I'll give this link in the description as well. So this is faucets.chain.link. So click that and then go back to your MetaMask and copy the account ID. So come back, paste the account ID here, and then unselect 10 test link, click I'm not a robot, and then click send request. So this will give you 0.1 test Ethereum. For this demo, you can do this twice, and if you have 0.2, that's more than enough. The reason I told you to do the second link instead of the first one, so first one is always busy and it doesn't work. So for the first one, you can get 3 Ethereum per 8 hours, and then you have to post a Twitter and a Facebook page. I'll give this link as well, but I haven't get it to work. I have to wait like long time. So I find the other approach much easier. So all right, at this point, the MetaMask is set up, and since this is a Chrome extension, we can connect this to any of the open browsers. So let's go back to our Remix editor, and what we want to do is connect our MetaMask to this Remix IDE. So I'm going to click this Chrome extension symbol and click MetaMask, and it says not connected. So click these 3 dots and then click connected sites and then manually connect to current site. And then click next, click connect. All right, so now this is connected to this Remix IDE. You might need to refresh the page after this. Let's go to deploy and then injected Web3. All right, so now you can select the injected Web3, and this account number is the same as our MetaMask account number. Notice that it also displays Ring-B test network when we selected the injected Web3. From the contract, select our 6-pack token, mytoken.solidity, and this is the initial supply. So I want to copy that, come back. So let's click deploy. This will create the token in test Ethereum blockchain. It says that, hey, to deploy this smart contract, estimated gas fee is 0.003 Ethereum. I say, okay, it's all good. Click confirm. All right, creation of 6-pack token pending. Transaction 3 confirmed. So to view any transaction on the Ethereum blockchain, either on the Ring-B test network or on the mainnet, you can select Etherscan. So click that. The status is success, and then this is the account number. So this account number, which is our MetaMask account number, has the full balance right now. So at this point, if you go back to MetaMask and you have this ring P test network, but you can only see the Ethereum. You don't see your token because you need to import it. So click import token, and then you have to give the token contract address. So if you go back to Etherscan and then copy this contract, go back to MetaMask and paste this contract address, and it should populate the token symbol. All right, add custom token, 6-pack, and I have 1000 6-pack. Click import tokens, and then if you reload the wallet, you should see the Ethereum as well as 1000 6-pack. So at this point, your account holds all the available 6-pack tokens. So regular folks cannot really buy it or transact on it because there is no token available outside your account. So basically, you need to create liquidity so that other folks can exchange their Ethereum token for the 6-pack token, so on and so forth. So you do that using an app called Uniswap. So if you just Google Uniswap, and you can also do this using PancakeSwap. So click this Uniswap and then click Launch App, and then select Connect Wallet, and then MetaMask. Click Next, click Connect. Now that we connected our MetaMask wallet containing the 6-pack token to the Uniswap, Uniswap will be able to detect and discover our newly created token. To create liquidity, select Pool and then click New Position. Remember that this token is ERC20 fungible token. That means that you can specify how many of Ethereum or other available token equal to how many of your newly created token. So I'm going to pair our token with Ethereum. So I'm going to click 6-pack and then 0.05% fee. And on the right, you have to determine the minimum and maximum price of 6-pack per Ethereum. So let's say minimum, I'm saying 500, and maximum, I'm saying 999. So it's going to change a little bit based on the fee. So basically, I'm saying that minimum 500 6-pack is equal to 1 Ethereum, and maximum price could be 998.9 6-pack is equal to 1 Ethereum. And then you have to set the current price. So I'm going to set the current price as 940. So currently 1 Ethereum price is equal to 940 6-pack token price. And then you have to determine how many token you want to transfer from your account to the liquidity pool. So currently I have 1000 6-pack token. So maybe, and then I have 0.6 Ethereum. So remember, you have to spend this much Ethereum to create this liquidity. So maybe I want to create liquidity worth 0.1. So that comes up to 851 6-pack tokens. I'll keep around 149 tokens. Click Approve 6-pack. Transaction fee 0.26. It's kind of expensive, but whatever. So you have to initialize the pool and then create liquidity. So we are just doing the initialization part now. All right, you have to select Preview again. This is where you are actually adding the liquidity. So I'm spending 0.09 Ethereum, and I'm going to add 851.2 6-pack token to the pool. All right, let's click Add. Okay, this is the gas fee. Confirm this. So at this point, you can swap or buy your token. So if you go to swap, and you can buy 6-pack for Ethereum, or you can buy Ethereum for 6-pack. So in this case, we are selling 20 of our 6-pack token to buy some of the Ethereum. All right, now to create your token in production, you can switch the network from Ring-B to Ethereum mainnet, and you have to have some Ethereum here. So I'm not going to do it because you need more than the 0.05 Ethereum. In test network, you can get free Ethereum, but in production, it costs actual money. But let me show you how you can do it. Now that your production MetaMask also has some Ethereum, so go back to Remix, and remember we deployed this in Ring-B 4 network. So click your MetaMask, and then switch from Ring-B test network to Ethereum mainnet. And then what that would do is that would change the environment in Remix to main network. And then you can put initial supply and click transact, and that will deploy the smart contract into the Ethereum mainnet. But this is the amount of Ethereum I have, 0.05. It's not enough. So if I click transact, so it says max transaction fee is 0.069 Ether. So even if I click confirm, this should be, it says 0.08, so insufficient funds, so it's not going to go through. So gas prices are quite high. So watch my previous video, what is gas price. So unless I pay this much gas fee, no one is going to mine my transaction. It's never going to go through. But anyway, if you have enough Ethereum in your production wallet, then you can go ahead and deploy this. And then you can go to Uniswap and then just do the same steps we have done. And then you can have your token in production marketplace. So a couple of things to keep in mind for production mainnet deployment. Number one, for test network, remember how we had to connect our MetaMask and then we had to swap and all that stuff. In production, once you create liquidity, then anyone in the world can find your token because all the DeFi marketplace, at least the Uniswap and PancakeSwap, you cannot really connect to test network. Everything is production. Only way to do this is using your wallet. But in production, you don't need to connect your wallet once you create liquidity. And the second thing is, see how I created this image for my 6-pack token, but I cannot really set it in our RinkB test network. But in production, you will be able to log into Etherscan using a login user ID password, claim that you are the origination account number for this token, and then you can set a picture. All right, folks, that's how you can create your very own crypto token in blockchain. All right, folks, hopefully this was helpful. If this was, please click that like button and subscribe. Each like helps this video reach new viewer and help this channel grow. All right, folks, that's it for this one. I'll see you guys and girls in the next video.